Record. Okay. All right. So here's the definition. A set of random variables are said to be independent and identically distributed random variables if, first, they're all independent. So the example that I would like you to have in mind is multiple coin flips. If I flip a coin and I get heads, and I flip the coin again, I get tails, the results actually are independent of one another, right? And the way that we define this mathematically is x1 and x2 are independent if the probability that x1 equals little x1 and the probability that x2 equals little x2 is just a product. Right? That was what it meant for two random variables to be independent. Okay? And then identically distributed, this is probably the easiest one. All of the random variables have to have the same distribution. So you can think of many Bernoulli trials, right? That's a distribution that we're pretty comfortable with now. Flipping n many coins is a set of independent and identically distributed random variables. Okay, so this definition looks kind of scary, but it's really not. I recommend you don't really have to write this one down. So just take a screenshot of this and you'll be fine. So the important parts are independence and identical distribution. Okay. By the way, I'm going to be copying and pasting things from my notes. So just give me a moment. Okay. Where's PowerPoint? One second. Here we go. So here's the definition of a normal distribution. What's the point of a normal distribution? I'll explain in just a moment. But a normal distribution is just a distribution with this probability density function. Okay? And so here's the definition. So definition, this is what you can write. The normal distribution denoted n mu sigma squared is the distribution with probability density function f of x equals 1 over 2 pi, square root of 2 pi sigma squared e to the minus x minus mu, mu squared, squared all over 2 sigma squared. Okay. So what is this really weird distribution? How is it motivated? I'll tell you in just a moment, but for now, please write this down. By the way, if you're watching this on my YouTube channel, I recommend that you watch at 1.5 speed. Okay. So here's another, so here's an example. The standard distribution, standard normal distribution is n of 0, 1. So this 0 is my mu, and 1 is my sigma squared, okay? Sigma squared is the variance, if you remember. So note Sigma squared is the variance, and mu is the mean, or the expected value. So what does this look like? N of 0, 1, the PDF, is defined f of x equals, let's look over here. Just give me a moment to copy and paste this. Oops. Oops. There we go. Ah, that's not what I want. Here we go. I think it would have been faster to just write it. Oh well. Okay, so this is going to be equal to, in this case, it's going to be 1 over square root of 2 pi times 1 e to the minus x minus 0 squared all over 2 times 1. So this is going to be 1 over square root of 2 pi e to the minus x squared all over 2. Okay. And that looks like this. I'll go back to that in just a moment. That looks like this. So please write this down.
Are you gonna upload the slides?
Should I?
I mean, if you're uploading the recording, I don't think it's necessary.
Okay. Somebody asks me to, I will, but otherwise probably not. Okay, so here's the statement. So why do we care about the normal distribution? It's because of what's called the central limit theorem. The central limit theorem will be presented in this class without proof. I think I've proven basically every theorem that I stated in this class. So, you can take this one on trust, or at least I hope you can. If not, the proof does appear in the book. So the central limit theorem basically says that if you have a bunch of um, independent and identical distributions for random variables, and their mean is mu, and their variance is sigma, then you can take this, what's called the standardized sum. The standardized sum is square root of n times the average of all the xn's minus the expected value of any of the xi's all over sigma. Okay? Then as n approaches infinity, the distribution of Zn converges to the standard normal distribution 0, 1. So what is this thing? This is sort of this is sort of, how can I say it? This is sort of the expected average of all your results. I'll put it that way. Okay. And it just so happens that this value approaches the normal distribution. And z of n approaches the normal distribution. Okay. This isn't exactly the expected value because you're sort of normalizing by the expected value and the square root of the variance. I'll give you examples of what that means in just a moment, but for now, let's just do some examples. If you'll notice this, to find, so if if x has the normal distribution, even if it's the standard distribution, in order to find probability that x is between a and b, I have to take the integral of from a to b of 1 over the square root of 2 pi e to the minus x squared all over 2. It's kind of annoying to have to do this integral every time. So what I'm going to do is on your exam, you'll get the following chart. Just give me 1 second here to pull it up.
Professor, can I see the previous slide?
Mhm. So,
Oh,
so
sorry,
this
I
is
missed it. I was taking a snippet of.
okay. So you can take that screenshot. Let me see how many people are here today. Okay. Okay. So this is what you'll use to actually evaluate integrals like this. How do you use this? I'll show you in just a moment. So this table will be provided for you on the exam, and it actually gets a little bit larger here. I'll write up the rest. You don't have to memorize this. Of course, you don't have to memorize this. These values will be given to you on the exam. You just have to know how to use it in order to solve problems. Okay. So just give me a moment here to summon up my example questions here. So if x is a normal random variable with parameters mu equals 3 and sigma squared equals 9, find the following values. So x is a normal distribution with the following parameters, 3, 9. This is not the standard normal, but it's a normal distribution, right? Normal distributions like Bernoulli trials are parameterized by a family. They're parameterized by these two variables, mu and sigma squared. And as it so happens, I'll write this in just a moment. The variance of the variance of x in this case would be 9, and the expected value of x would be 3. So you parameterize by these values. Okay. So let's solve this. How do I find out what is the probability that x is between 2 and 5? Okay. So let me write the solution here. Okay. So part A goes like this. We say, okay, to find the probability that x is between 2 and 5, we actually have to um, standardize this. So what does that mean? What you do is, I know that x has distribution, is a normal distribution with with a mean of 3 and a variance of 9. So what I'm going to do is I'm going to turn this into a standard normal distribution. So this corresponds to n of 0, 1, right? But this is not n of 0, 1. So what should I do? Well, it turns out that you can scale this funny distribution. So what does this distribution look like? This one looks like something like this. You can, if I move this over by 3 units and I scale it down by a factor of 3, I'm actually going to end up, so if I, do x minus 3 over 3, I'm actually going to end up with the normal distribution 0, 1. Okay. And then I'll be able to solve the problem. So this is equal to the probability that 2 minus 3 over 3 is x minus 3 over 3 is between 2 minus 3 over 3 and 5 minus 3 over 3. And that's equal to probability of, let me call this z now. I'm just going to call this z. Okay. And this is going to be equal to phi of 2/3 minus phi of minus 1/3, right? So that's how we're going to use this chart here. So hold on, sorry. Let me just continue on like this. So if you'll notice, there are actually no negative values on my table here. So how am I going to find out what is phi of minus 1/3? Well, phi of minus 1/3 is actually 1 minus phi of a third. Okay, so that corresponds to the fact that phi of minus x is 1 minus phi of x. Okay. So what that means is phi of 2 over 3 minus phi of minus 1/3 is actually, wait, did I get this right? Yeah. Why are the numbers not turning out correct? Oh, no, they are. Minus phi of 1/3. Does everybody understand this step? How I went from this to this? Yes? You can write in the chat, by the way. Does anybody not understand how I did that? Okay, well, if there are no questions, I guess I'll proceed. Okay, so now I want to compute these values here. What is phi of 2/3? Oops. What is phi of 2/3 here? So 2/3 is approximately 0.66. So I'm going to go, this is 0.6, and this is 0.6, so that's going to be 0.74 5, 4. 4, 5, 4 minus 1 minus phi of 1/3. Phi of 1/3 is approximately equal to 0.33. So I'm going to do 0.33. And so that's 0.6293. And when you do all the arithmetic out, you should get 0.3779. Approximately. Okay. So is everyone all right with this one? That was number A. Are there any questions about this? Should I go back to any previous slides? By the way, can everybody hear me? Still hear me?
Yes, yes, we can.
Yeah.
Okay. Oops. Oh. All right. So that was pretty good. Now let's do number B. So B was asking, find the probability that x is greater than 0. Oops. This was A. B is asking find the probability that x is greater than 0. Okay. Well, let me do that here. Let me just paste the solution into my PowerPoint. Okay, so in order to do this, again, since we're not using the standard distribution, we're using n of 3 comma 9. So in order to find this answer, we have to normalize x. So I'm going to divide by, sorry, I'm going to subtract mu, and I'm going to divide by sigma. So this is my mu comma sigma. And that's going to be p of, oops, sorry. When I plug the numbers in this particular case, it's x minus 3 over 3 is greater than negative mu over sigma. So this is probability, sorry, negative 3 over 3. This is probability of, let's just call this z, is greater than minus 1. Okay, but I know how to do p of z is greater than minus 1. That's just going to be equal to 1 minus p of 1, right? What's phi of 1 here? Oh wait, I'm making a mistake. Where is my mistake? Sorry.
How does x minus 3 over 3 evaluate to 2?
X minus 3 over 3? What do you mean?
Sigma shows us 9.
Oh, wait, 1, 2, 3, 4. Which line are you guys talking about?
4. Oh, I'm talking about 4.
What happened there? This is just x minus 3 over 3 is greater than or equal to, is greater than minus 3 over 3.
Shouldn't be over 9. X minus 3 over 9.
No, because you divide by sigma,
Okay.
not sigma squared. Oh, sorry. This is sigma squared. Does it make sense? To normalize, you actually divide by the square root of the variance, which is a standard distribution. Sorry, which is a standard deviation.
Okay.
Mhm. So this is P of x minus 3 over 3 is greater than minus 1. And um, hold on, why am I making? Okay, I see what I did wrong. Okay, so this is equal to 1 minus phi of minus 1. So let's look up here. Or actually, let me draw the picture. I want to find the area under this curve, right, up to this point. Um, so, sorry. Sorry. I meant this. Okay. Um, so phi of sorry. This is what I'm trying to write. Okay, good. So sorry. I wrote this wrong again. Okay. So this normal distribution actually trails off from minus infinity to infinity. So the area under the whole curve should be 1. So what this is saying is you need to do 1 minus phi of minus 1. And this is 1 minus phi of 1, which is just phi of 1. And that's equal to 0.8413. Sorry, this should have been a z. Is this clear, by the way? Any questions? No? All right. So Zoom says I only have 8 minutes left. What does that mean? That I can only record for 8 minutes?
Are you using your college email? Because if you use the college email, that doesn't happen.
No, I am using I'm using my CUNY email. I
Yeah,
logged in with CUNY.
I think you need to talk to the administration then, because most of it is free.
Oh, okay, that's strange. So I guess are they going to close are they going to close this? Um, hmm. I don't know what to do in that case. Um, okay, maybe if this closes, I'll make another Zoom link and we'll reconvene for 5 minutes. Or maybe, maybe I'll just do one more question and it'll be fine. Typically, I would just have you guys do questions. All right, I don't think I'm going to touch C. I'm going to do another one. So let X have the standard normal distribution. Find the probability that X is between -1, no, 2 and 1. Okay. So the way that we do this is that this is just going to be phi of 2 minus phi of 1. Why is this what's happening? Well, this chart tells you what the values, what the area under the curve is for these values. So if you were at, let's say, 0.9, here's 0.9, the area under the curve up to 0.9 is 0.8159. Okay, fine. So in order to find this, think about what's happening in the picture. Here's my standard distribution, standard normal distribution. I want to find phi of 2. That's going to be this whole area. But then I want to subtract off phi of 1, which is this whole area. Okay. I'm only interested in this area here. So I'm going to do phi of 2 minus phi of 1, which in this case, let's see. Since I'm doing 2.0, 2.0, it's 0.9772. Minus phi of 1, which is, let's see, okay, here's 1 comma, and here's 0.00, so minus 0.8413. Okay, and I don't really care what the number is, you could just plug into your calculator, but that's the idea, okay? All right. Is that clear for everyone? Now let X have the standard normal distribution again. I want to compute what is the probability that X is greater than 2. Okay. Sorry, X is less than 2. No, X is greater than 2. Okay. So that's going to be, so I always like to draw the picture. Here's 2. What's the probability that X is greater than 2? That's this distribution. Sorry, that's this portion of the graph. So this portion of the graph is actually phi of 2. And the whole thing is, you know, so as it just so happens, the whole thing, since it's a probability density function, needs to add up to 1. So the whole area is 1. And so what is this going to be? This is going to be the whole area minus the red part. So that's 1 minus phi of 2. And again, that's going to be 1 minus 0.9772. I think those were the numbers. Okay, and that's going to be some number. I'm not going to compute it. You can just put it into your calculator. Okay. Again, I want to emphasize this because n of 0, 1, because on the original definition here, where is it? Because this is a probability density function, there's always a probability density function, the whole area under the curve is going to be equal to 1. Okay. Okay. Now we'll do one more. let x have this normal distribution with mean of 3 and variance of 4. Find the probability that x is between 7 and 9. Okay, so let's do this. How are we going to do this? Well, this is not, if you were to draw this, the probability density function for this distribution would look something like this. The mean is 3 and the standard deviation is 2. Okay, but I actually don't have the chart corresponding to the area under the curve for this graph. So what I'm going to do is I'm going to say, and I have to go really quick here, since I have a minute and 30 seconds, this is going to be, I'm going to subtract off by the mean and divide by the square root of the variance. So this is equal to 7 minus 3 is 4 over 2 is 2. I'm going to call this z. And this is 6 over 2 is 3. Okay. And that would just be phi of 3 minus phi of 2. And hopefully you know how to use this chart. You could figure out what those numbers are. Okay, so since this is about to end, I think we'll stop there. That's the normal distribution. And the motivation for it was given by the central limit theorem. Okay. All right, guys, so thanks a lot. I'll see you.
Sorry, Professor, will we get a packet 5 next, this
Problem
Wednesday?
set 5?
Yeah, problem set.
I don't think there will be a problem set 5.
Oh, okay.
Mhm.
Thanks.
Thanks, guys. Okay. If you did all of the problem sets, you're in good shape. You don't have to worry